Part B, similarity and dissimilarity in the complaint profile. Question number 1, briefly outline how to compute dissimilarity between a complaint profile described by a nominal attribute, B asymmetric binary attribute, C numeric attribute, D term frequency vector. Answer: A nominal attribute, a categorical variable, is a generalization of a binary variable in that it can take on more than two states. The dissimilarity between two objects j, I and j can be computed based on a ratio of mismatch dij equals to p minus m by p, where m is the number of matches, that is the number of variable for which I and j are in the same state, and p is the total number of variable. Alternately, we can use a large number of binary variable by creating a new binary variable for each of the m nominal states. For an object with a given state value, the binary variable representing the state is set to 1, while the remaining binary variable are set to 0. Asymmetric binary attribute: if all the binary variable has the same weight, we have the contingency object j, object I. If 1 1 then q, 0 1 then s, 0 0 t, 1 and 0 r. The sum is r plus q plus r, s plus t, q plus s, r plus t, and p. In computing the dissimilarity between asymmetric binary variables, the number of negative match t is considered unimportant and thus is ignored in the computation. That is dij equals to r plus s divided by q plus r plus s. See numeric attribute using Euclidean distance or more another distances. Euclidean distance are defined as dij equals to root xi1 minus xj1 whole square plus xi2 minus xj2 whole square till xin minus xjn whole square. The numeric attribute using Euclidean distance, Matterhorn distance, or supremum distance. Euclidean distance are defined as dij equals to mod xi1 minus xj1 plus mod xi2 minus xj2 till xin minus xjn. Supremum distance is given by this formula. D term frequency vector to measure the distance between complex objects represented by the vector. It is often easier to abandon traditional matrix distance computation and introduce a non-matrix similarity function. For example, the similarity between a two vector x and y can be defined as a cosine measure as follow: x as xy equals to x to the power t into y upon mod x mod y, where xt is the transposition of a vector x, mod x is the Euclidean norm of a vector x, y mod y is the Euclidean norm of vector y, and s is essentially the cosines of the angle between vector x and y. Question number 2. Let tuple case are 22, 1, 42, 10, and 20, 0, 36, 8 representing incident duration minutes and witness present 0/1. Evidence item count, alert count. Compute the following distance among A. Euclidean distance, B. Manhattan distance, C. Minkowski distance with h equals to 3, D. Supremum distance. Answer: A. Compute the Euclidean distance between a two objects. The Euclidean distance is computed using the equation. Therefore, we have root 22 minus 20 whole square plus 1 minus 0 whole square plus 42 minus 36 whole square plus 10 minus 8 whole square equals to root 45 equals to 6.7082. B. Compute the Manhattan distance between two objects. The Manhattan distance is computed using an equation. Therefore, we have mod 22 minus 20 plus mod 10 1 minus 0 plus mod 42 minus 36 plus mod 10 minus 8 equals to 11. Compute the Minkowski distance between the two objects using h equals to 3. The Minkowski distance is dij equals to under root mod xi1 minus xj1 h plus xi2 minus xj2 mod h till xip minus xjp mod h, where h is the real number such that h is greater than or equal to 1. Therefore, with h equals to 3, we have under root 22 minus 20 mod 3 plus 1 minus 0 mod 3 plus 42 minus 36 mod 3 plus 10 minus 8 mod 3 equals to root 2 cube root or 233 is 6.1534.